Now in this problem right here, we're given a graph of the function and we are required to write down the function. So the first thing right here, when I want to write down a function, by looking at this graph, I know that I have x-intercepts at x equals -2. And I know that I have x-intercept at x equals 3. Notice both of these intercept has a multiplicity of 1. Meaning the power of these factors, they're both gonna be 1. Now after I find my x-intercept, I am gonna find my y-intercept, and I know that right here my y-intercept is at -2. Y-intercept at -2. So here I'm gonna write it as a point. So 0, -2. Now I need to find my vertical asymptotes. The red line right here are my vertical asymptotes at x equals -1 and at x equals 2. Now at x equals -1, notice that my graph around this vertical asymptote, they go opposite directions. Since they go opposite directions, I know that my power of this factor is going to be 1. And now at x equals 2, they both go the same direction. That means that the power of this function is going to be, the power of this factor is going to be 2. So now here, I need to find my horizontal asymptote is at y equals 0. We can see that as my x goes to -infinity, my function reaches 0, and at x equals to +infinity, my function reaches 0. So now right here, I am ready to write. So whenever we have a rational function, remember that the numerator are the x-intercepts value. So now right here, I need to write them as a factor. So x plus 2 and x minus 3. Both of these power are to the power of 1 since they have a multiplicity of 1. And now don't forget the a value. Right here, in every function, we will use the y-intercept to solve for my a value. So now after I have my x-intercepts, which go in the numerator, I know that my denominator is always going to have the vertical asymptote. So now here my vertical asymptotes are at x plus 1 has a power of 1, and x minus 2 has a power of 2 because of the movement of the graph as it reaches this vertical asymptote. Now I am going to use my y-intercept to find my a value. So I am going to plug -2 equal to a. For every x I put is 0. 0 minus 3. 0 plus 1. 0 minus 2 squared. So that's going to give me -2 is equal to -6 over 4a. Multiply both sides by 4. -8 is equal to -6a. A is equal to 4/3. So after I found my a value, I am ready to write my final solution. So my function that represents this graph is going to be 4/3, x plus 2, x minus 3, x plus 1, x minus 2 squared. Now in this problem, we are asked to describe the long-run behavior of this rational function. So remember, the long-run behavior is always indicated by my horizontal asymptote. So in this right here, to find my horizontal asymptote, I am going to look at the leading term from the numerator and the leading term from my denominator. So right here, the leading term of my numerator is 3x squared, and for my denominator is x. Now, since my numerator has a degree greater than my denominator, I know that I have no horizontal asymptote. However, whenever your numerator has 1 degree more than the denominator, so now right here, notice the denominator has a power of 1. My numerator has a power of 2. So whenever the difference between these powers are a 1, then here we have something that is called an oblique asymptote. And the way we find that asymptote is by doing long division on the function. So my long division here, the numerator goes inside 3x squared plus 2, and the denominator goes outside. So here I am gonna apply long division. So to get a 3x squared, so I take my first term from the inside divided by the leading term from the outside, and that gives you 3x. The 3x goes here. Multiply it by each term, I get 3x squared minus 15x, subtract, and now I get 15x plus 2. Now here I know it's a plus 15 by taking the leading term, dividing it by the leading term from the outside, it's 15. Multiplying it gives me 15x minus 75, subtract, 15 goes away, and now I am left with 77 as my remainder. So now my oblique asymptote is always gonna be the function I get as my quotient. So now right here, 3x plus 15 is my oblique asymptote. So remember, to obtain that asymptote, all I have to do is the long division, and the only time I would have that asymptote is when the power of the numerator is 1 degree higher than the power of the denominator.